So we're asked to find the derivative of y with respect to x for this particular equation. So looking at this straight up, I know that I can use the chain rule in order to figure out the derivative. And that's because I have this x stuff tied up inside a sign, but the x's aren't multiplied by any other x's outside of the sign, so we don't need to use the product rule. So I'm going to do this firstly using the really formal way of using the chain rule, and then at the end I'll show you the more direct way. So if we're using the chain rule, we need to introduce a new variable for like the complicated part of our equation. So in this case, we're going to let this 20x cubed plus 4x minus 3 equal our new variable, and often people use u for whatever reason. So let's go with that. Sorry, plus 4x, take 3. Alright, so now we need to take the derivative of u with respect to x, and that's going to give us du dx. So this is just a straightforward polynomial now. So top number times the front number gives us 60. X might take one off the power, leaves us with 2. The derivative of 4x, applying the same rule, is just going to go to 4. And the constant, the derivative of that is 0. So now we've got the derivative of u with respect to x, which isn't quite what we wanted. We wanted y with respect to x. So we can rewrite ourselves a new rule to get dy dx, and it's going to be equal to this one that we've just worked out. And then what we need to do is we want the top line to be dy, so we need a dy on the top line, and we want the bottom line to be dx, and we've already got one of those, so we're going to have to cancel the top line and the bottom line here to get rid of the du's, so that's where it comes from. So the derivative of u with respect to x that we just worked out, multiplied by the derivative of y with respect to u, which we will be able to work out in a moment, leaves us with just this, and you can see that these kind of cancel with each other. So let's go back now and figure out dy du. So we've got y, and we can write this as being equal to 12 times sine, and we've said that this stuff in here is equal to u. So we can just say it's 12 sine u, and now we can take the derivative with respect to u, which is what we were looking for. So 12 stays out the front, sine goes to cos, and u stays inside the bracket. So that's now our derivative that we can sub in up here. So let's go ahead and do that. So du dx was equal to this, and this is equal to this. Alright, so to conclude the question, we want to make it look a little bit nicer, so I might bring this 12 out the front. And then rather than having this random variable u that we've introduced, we can substitute it back to be in terms of x, which is what we started with. So change it back to 20x cubed plus 4x minus 3. So that there is the answer to the question, and of course if you're keen you could do a little bit more factorizing in there, but I'm not going to bother. So let me just quickly show you the kind of shortcut way if you were to work off this equation to begin with. Alright, and it's just applying these rules except doing a little bit of the process in your head. So I'm going to get y dash, or the derivative dy dx, same thing, as being equal to, so I keep the 12 out the front, I take the derivative of sine, so sine goes to cos, I write out whatever is in the bracket, so 20x cubed plus 4x minus 3, and then I need to multiply by the derivative of what's inside the bracket. So we're going to have 3 times 20, which gives us the 60, take 1 off the power, which leaves us with x squared, and we said this goes to 4, and this goes to 0. And what you're going to find is that this is exactly the same as what we had a moment ago, except that obviously I've done it in 2 lines rather than a whole bunch of other working that we had to go through. So this answer is the same as this one, so whichever way you do it, you should get the same thing. So that's all there is for that video, and I'll see you in another one.